Okay, so here is your helper video to get you ready for the Learning Target number 3 quiz. So here are our learning targets right here for number 3. Before we get started, I want to talk about the formula packet, and I want to talk about the graphing calculator. So you can use your graphing calculator kind of to check your answers on your derivatives with your functions, but I haven't figured out a way to totally do it, just sort of kinda, so it's not as good as Desmos, but we're not allowed to use Desmos on the IB exam, so therefore I'm not going to let you use Desmos on my quizzes. So have your graphing calculator handy. All right, the other thing is the formula packet. So you can see all the derivatives are here. Everything we've talked about, they're all here. So this quiz is going to cover all of these, right? So here's the basic derivative, sine and cosine. Oh, tangent. No, it's not going to have this one. I forgot. We haven't done that one yet. Okay, so you don't have to worry about using that one. But e to the x, natural log of x, chain rule, product rule, quotient rule. Okay, so if you look at these and you go, oh my God, these are insane. What are these saying? Just remember that if you can have a function that is a composite function, okay, so it's a function inside of a function, that you can get the derivative by doing the function of g of x and f of x and multiplying them together. Okay, so if it's a composite, a function inside of a function. So the way they have this written is a little bit confusing. So, but basically it's showing the u substitution. So if you have a function and you can substitute in u, and u is equal to some other function, if you take the derivative of u, so that would be the du dx, and multiply it by the derivative of g, that would be this dy du, you can then multiply them together. So I really don't like this notation here. Oh my God, this is horrible now that I think about it, because they're using g and f and then they don't use them at all over here. So anyway, if you have separated your composite function into two functions, you just take the derivative of each of those functions and multiply the two derivatives together. So you can see here they're showing two derivatives multiplied together. But yeah, that's really ugly. Okay, this one's a lot better. So if you have two functions being multiplied together, then you take the first function times the derivative of the second function, see the dv, plus the second function times the derivative of the first function. So that one's much more straightforward. Now, if I still don't like how this is written, if I still don't like that, I could rewrite it on my test paper. So please don't write in my formula packets, but you could write it. You could write product rule. Another way of writing this one is to write y equals u times v. So therefore, the derivative of y is equal to u times the derivative of v plus v times the derivative of u. That's the simple way of writing it, but that's the same thing as this. Okay, same idea for the quotient rule. If you don't like how it's written here, the quotient rule, you could write it on your paper right away. You could say, okay, the derivative of the function, if the function can be written as u over v, then the derivative of the function is going to be v times the derivative of u minus u times the derivative of v, all divided by v squared. So that's a simpler way. Oops, I'm off the edge. This is a simpler way of writing what they have here in the formula packet. Okay, so if you find this hard to follow, hopefully you can realize this du dx, that's just the derivative of u. dv dx, that's just the derivative of v. And then you can rewrite it like this if that makes your life easier. Okay, same with the product rule. Okay, this chain rule though, the way they wrote it here on the formula packet, I think the easier way to write the chain rule is if you have f of g of x, okay, so if y is equal to f of g of x, then the derivative of y is going to be the derivative of f of x times the derivative of g of x, basically like that. Okay, so if you have a composite function, you can separate them and then just multiply the two derivatives together. That's not how they show it, because they kind of use the u and it's kind of funky, but that's the basic idea. All right, so getting back to our actual problem set, I'm going to start with level 1. So level 1, the basic 1A, It says y is equal to the natural log of x, find the derivative. All right, this is either use your memory or use the formula packet, nothing tricky here. The dy dx is going to be equal to 1 over x. Okay, so I'm just using this. And notice they gave me the function as y equals, so therefore I need to give the answer in dy dx. Okay, letter B, they give me f of x is equal to sine of x, so therefore the derivative is going to be f prime of x. And again, I can just use my formula packet. This one's in my formula packet. Absolutely no excuse for making a mistake here. It's just cosine of x. So I'm just looking it up. Okay, letter C, it has f of x equals x squared minus 4x. Okay, this is basic derivatives. I think everybody's pretty good at this by now. There is the little reminder in the formula packet, which is showing you if you have x to the power of n, the n comes down in front, and you subtract 1 from the n. So there it is if you need it. So my derivative, 2 brings down in front, x, 2 minus 1 is just 1. Okay, this one has an invisible exponent of 1. 1 times negative 4 is negative 4. If I subtract 1 from my exponent, 1 minus 1 is 0. X to the 0 is just 1, so there's my answer. Okay, basic. Okay, and then letter D looks a little bit fancier, but notice it is just the same stuff that we already did, just being added together. So when you're finding the derivative of a sum, you just find the derivative of each piece. So real straightforward. So what's the derivative of cosine? Derivative of cosine, it's in my packet. Derivative of cosine is negative sine. So negative sine of x. And then what's the derivative of e to the x? The derivative of e to the x is e to the x. And then the last one, that's e, sorry, that got messy. And then the last one, what is the derivative of 5x to the 4th? Well, 4 times 5 is 20. X to the 4 minus 1 is 3. Okay, so when you have a sum, you can just take the derivative of each part separately. It doesn't matter what those parts are. Notice I have a cosine, I have an e to the x, and a 5x to the 4th, and take the derivative of each one. Okay, so how can we check this in our calculator? So if you want to check it, what you can do is you can first put in your function, so natural log of x, and then put in your derivative, 1 divided by x, graph it, and let's see, the first one, oh, shoot, I just remembered, guess what I forgot to do? I forgot to put the domain limitation, because notice the function is the blue one, and I do not have a blue piece over here. Okay, this one's a little tough. I don't think I can actually check this one on the graphing calculator, because the way we're going to check these is by checking the minimum or the maximum of the function and making sure that is the x-intercept of the derivative. So, but this one doesn't have a derivative because there is no maximum or minimum. But this did remind me that I forgot to put in the limiting value. So the limiting value here is going to be x has to be greater than 0. Notice on my original function, x is always greater than 0. So x is always greater than 0. When we have a natural log, we have to use this to help us find our limiting value. Okay, I don't know if we can put that into the calculator. I don't think we can. So we can't check that. Sorry. I do not know how to check that on the graphing calculator. Okay, so that was a bad example. Okay, let's check the next one. Let's go to change my functions to sine of x. Oops, I wanted to put that up here. Sorry. Sine, where am I? Sine of x. And this one would be cosine of x. And if I graph those, now this one we should be able to check if these make sense. So the blue line is, or the blue curve is my function, and the derivative is the red one. Now, we know that when you have a maximum or minimum value, the slope right there is 0. And the derivative tells you the slope at a given point. So right here, at my maximum value here on that blue line, I have a slope of 0. So check the red line. At that x value, right there, I have my x-intercept. The coordinates of that point looks like it's 1.5, comma 0. My x-intercept needs to line up with my maximum or with my minimum. So look for your maximums and your minimums in order to check and see if your derivative makes sense with your function. And now somebody is at my door. I have to take a